Students, so we were discussing a topic related with the laws of motion. We have discussed some questions related with the laws of motion. Today I will be discussing one more problem related with the laws of motion, that is about apparent weight. Now what do you mean by the apparent weight? I think you have seen when you go to the railway station, you will see a weighing machine there. You have to put a coin there, and when you stand over the weighing machine, weight measure shows on the above scale. One scale is there. Like suppose if you see this one, this is a weighing machine. Here your measurement will be shown. Okay, then we have to stand over this one. Okay, we have to stand over this one, and you put a coin there. So when you put a coin there, your value will be showing this. What is the weight of your body? Now how does the weight is being measured? That we need to see. Like suppose we have discussed about the Newton's third law of motion, that every action has equal and opposite reaction. So when you stand over the weighing machine, okay, when you stand over the weighing machine, your weight will be there on the weighing machine. Okay, so that will be acting towards a downward direction. So if I write it here, this will be your weight mg, which will be towards a downward direction. W is equal to mg. Okay, this vector, the B7 that is written here. Similarly, if you consider this, the above one, this will be the reaction force. Every action has equal and opposite reaction. So when you stand over the weighing machine, so weighing machine also will be giving a force to your body. That will be your reaction force. And the value that you get on your weighing machine here, okay, the value that you get on your weighing machine here, this is nothing because of the reaction force. Okay, the value that shows, it is only because of the reaction force. Okay, so the weight shown on the weighing machine, this is called as the apparent weight of the body. Okay, so what we have to write in the apparent weight of the body? The weighing machine measures the normal reaction force on your body. Okay, normal reaction force on your body, that is called as the apparent weight of the body. Okay, so that you have to write. So now we need to find out what will be the apparent weight. Okay, what will be the apparent weight? If I put this weighing machine on the lift, okay, if I put the weighing machine on the lift, and if the lift move upwards, what will be the weight? If the lift move downwards, what will be the weight? And suppose if I cut the lift cable, okay, if I cut the lift cable, then what will be the weight of your body on the weighing machine? That we need to calculate. So we'll be doing 3 questions based on that. So the first question, what we have to do, you have to write, find the apparent weight of a person. Just write as a question, find the apparent weight of a person standing on a weighing machine placed in a lift. Okay, placed in a lift. When lift is, number 1, moving upward or downwards with constant velocity. Number 2, moving upwards with an acceleration a. Number 3, moving downwards with an acceleration a. And number 4, falling freely. Okay, and we have to define what is weightlessness. So this is your question. So let us discuss the first one, when the lift is at rest or moving with constant velocity. So number 1, when the lift is at rest or moving with constant velocity. Constant velocity, that means the velocity will be always equal to 0. Constant velocity, uniform velocity. So we consider that as a rest. So if you consider that as a rest, when you put it inside a lift, okay, when you put it inside a lift, the weight that will be showing by your weighing machine, this will be your R equals to mg. That means it will be showing your actual weight of the body. Okay, so this is our first one. So let me move to the next question, question number 2. Let me wrap the whole part. Question number 2. When the lift is moving upwards with acceleration a. Okay, moving upwards with acceleration a. So what will be the weight of the body? So if you consider the weighing machine, your body is moving upward. So if I consider the total force acting on the body, so total force acting on the body will be writing as F will be equals to, if your lift is moving upwards, so obviously the reaction force will be more than its weight. So if I calculate the total force, so we can write as R minus of M into G. Okay, because reaction force is more and both are acting opposite to each other. So R will be, we have to write first, then we have to write about the mg. Then if I write that force is equal to mass into acceleration, so it will be R minus of, sorry, it will be small letter mg. We need to find out the value of R. So that is only the apparent weight. So R will be equals to ma plus mg. So what we have got, we have seen that if your lift move upward with an acceleration a, since we have got the sum of ma plus mg, this means that your actual weight was mg. So when the lift move upward, one additional force has been added, ma. That means when the lift move upwards, your actual weight, that is the apparent weight of the body, will increase. Okay, you have to write, so the apparent weight will increase. Okay, when the lift move upwards with acceleration a. Let us see the third question, downwards with acceleration a. So if I rub it downwards, okay, downwards with acceleration a. So if I move, consider the downwards with acceleration a, again if I consider the total force, here what will happen? Here your weight will be more than the reaction force. So your weight will be, if I, let me rub it. Here what we have to write, here your weight minus of the reaction force, just the opposite of that one. This will be your ma, will be equals to mg minus of r. So what we have to do, we have to calculate the value of r. So what will you get? If I interchange this side, so it will be mg minus of ma. Now you can see, if you compare with the previous equation, we have got mg minus ma. This means that the value of your actual weight, that is the apparent weight of your body, when the lift moves downwards, the value of your apparent weight decreases by how much? By a value of minus of ma. So you have to write, so the apparent weight decreases. Okay? So this is question number 3. Let us move to question number 4. So our question number 4 is, when the lift moves freely, when the lift moves freely, that means when I cut the cable of your weighing machine. So when you cut the cable of the weighing machine, then what will happen? The value of your reaction force, that means since it will be moving downwards, so force will be equal to, we have got as mg minus of, reaction force we have got as mg minus of ma. Okay, mg minus ma. So since it is moving downwards with the acceleration due to gravity, the value of your force and the value of your this weight, okay, this both will be equal. Okay, both will be equal and it will be falling only under the action of gravity. So your value will be equal to 0. That means your reaction force will be equal to 0 and the apparent weight that will be showing on your machine will be equal to 0. This condition is called as a weightlessness. Okay, so this is what we have to discuss. In the next class, we'll be discussing some more topics related with this.